Today we're going to prove triangles congruent by side, side, side. So if triangles are congruent, for example, and if triangles are congruent, complete the congruent statement and give a reason why they are congruent. So in the first one, we have DFG, so this triangle going from D to F to G. We have to see if it's congruent with this triangle right here. And notice how we have marks, one tick mark, that means that those two sides are congruent, these two sides are congruent, and these two sides are congruent. So if all three sides are marked on both triangles, then we can assume that those two triangles are congruent. So I would write, starting with D here, I have to start with H here, because it's in between my one tick mark and my two tick marks. So I go in between my 1 and my 2, and I write H, so triangle H. And then I go to my next one, which in this triangle went from DF to FG. So now I have to slide down the same way. So H, J to K. Looking at example B, we have A, C, B. So going from A to C to B in that direction. Now if I look at this AC, if I take these triangles apart and I mark sides that are congruent, this side is the same as this side, so they are congruent. I'm talking about this line right here. They're the same. And AD right here is the same as BC right here. So I would mark those congruent. So I put 2 tick marks because they're not the same length. But if I'm looking at CD and BA, this one's 4 and this one's 3. So those two sides right there are not congruent. So this would be there are no triangles available that are congruent because AB is not congruent to DC. Looking at example C, again I look at, do I have 3 sides of the triangle that are congruent? And I do for both of them. So QPT, from Q to P to T, I have to go in that direction when I write this order. So I'm going to start with in between the 1 tick mark and the 2. So in between the 1 and the 2 here, right here in the 1 and the 2, is R. So I'm going to write R, so triangle R. And then when I looked at this other one, this other triangle, I went from Q to P to T. So I went up and then down. I slid down where it's 3 and 3. So the next one would be T for me here. So R, S to T. Now moving on to example 2. Use the given coordinates to determine if triangle X, Y, Z is congruent to triangle GHI. So when I'm doing this, I need to make sure that the sides X, Y are congruent to GH. So I'm going to put XY here and GH here because they need to be the same. So I find the distance formula, or I use the distance formula for that to find the length. And to make sure that's a plus sign for you. From X, this is my X1, so I'm going to subtract my X's, and my Y is -1. And I have 4 for my X is -5, and my X for Y is -1. My Y for X is 4, and my Y for the point Y is also 4. So I would say, well, -5 plus 1 is -4, and -4 squared is 16. 16 plus 4 minus 4 is 0. 0 squared is 0. So my answer here is radical 16, which equals 4. Then I go over to this side, and I do the distance formula. I'm going to go from G to H, so I'm going to use these two right here. I have -1 minus -1, which becomes a positive, So -1 minus -1 is 0. Plus, over here I have 1 minus 5, which is -4. -4 squared is 16. So radical 16 equals 4. So these two sides match up. They are the same. Then I go to YZ. And I do the distance formula again. Y is -1, Z is -1 for my x's, and 4 minus a 1. So that becomes, so we have a positive here. And so -1 plus 1, or plus 1 is 0. So I have a 0 here, plus 4 minus 1 is 3, and 3 squared is 9. So really the square root of 9 is 3. And then I match up the same side over here, and YZ is right here, so that matches up with HI. And I do the distance formula. H is negative, or the x and h is -1, and the I and, or the x and I is -4, so that becomes a positive, and two negatives are next to each other. And that would be -1 plus 4 is 3. 3 squared is 9. Then I subtract my y's, and I have 5 minus 5, which is 0, and 0 squared is 0. So the square root of square root of 9 is 3. So again, these two check, and these two check. So two sides are the same. So then I check my third side, which is XZ. Change this to green so you can see. So, oh, I'm sorry. That's the wrong one. So let's erase that. I'm not doing XZ. We are doing XZ, but I wrote ZY. So let's make sure I'm writing it right. We have XZ here. X is -5 minus a -1. And then my y's are 4 minus 1, so that becomes a positive, and -4 squared is 16, plus 3 squared is 9, which is radical 25, which is awesome because that becomes a 5. And then we have over here GI. We need to find the distance from there, so I use the distance formula. And G is -1 minus a -4, and 1 minus 5. So that becomes positive. We have 3 squared, which is 9, plus 4 squared, or -4 squared, which is 16, and that is a radical 25, because this all should be under the radical, and that is 5. So they check too. So if all three of these are the same as these, then it is a triangle. For B, I shortened it up a little bit for you so you could see, or we could save some time here. So I put part of the formula in there for you. So I'm looking at HI, so I have 10 minus 4 and -3 minus 1. So 10 minus 4 is 6. 6 squared is 36, plus -4 squared, which is -3, and -1, which equals -4. -4 squared is 16. So I should have a 16 there, and that equals, we have a 52, radical 52. And right there I can say, this side is different than this side. So no, it's not a triangle. That's congruent. Okay, and on to the back page, we have some proofs that we're going to try to fill out. We have KL, we know we start with our given, is congruent to NL, and that is a given. Number 2, I'm going to mark that. Actually, it is marked already. KL is congruent to LN with 1 tick mark. And then we have KM is congruent to NM. That is given. So KM and MN is proven, or is given, so we have that. And the last one is not given to us, but we can see that LM is the same as LM because it's the same line for both triangles. Here, this is the same line for this one, it's the same line for that triangle. So we're going to mark that as the reflexive property. Now that we have all of those marked, we'll mark that with 3 congruency marks. Now all 3 sides are congruent to 3 sides on another triangle. I can say that triangle KLM is congruent to triangle NLM because of side, side, side. So when I go back and look at this, I try to mark this is a side, this is a side, and this is a side. I didn't really leave room for that. So I know that I'm proving a side, side, side. Looking at number 2, we have AE is congruent to CE, and so that's given. And this is where I would put an S here, because I just proved one of the sides congruent. So AE, I'll mark that on my paper, AE is congruent to CE. And then I go to the second given, which is AB is congruent to CD, given. So AB and CD. And then the third one is not the same for both triangles like we did in our last example. They are not sharing that side. So what I know is our next given tells us E is the midpoint of B, that's a B, BD. That's given. So if E is the midpoint, then I know that if midpoint, then 2 congruent sides. So my 2 congruent sides here are BE and ED. So BE is congruent to ED. Now I have all 3 sides marked, so I can say, so this is a side, and this is also a side. So I have side, 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 side. And I would mark number 5, triangle EAB is congruent to triangle ECD by side, side, side. Okay, moving on to see if something is stable or not. And by stable, I mean a figure with a diagonal support. Support at the base. So I'm looking at the base, and is there a diagonal that cuts through here? And I would say no. So is this stable? No. No, because no diagonal. B, I would say this is my base, and there is a diagonal, so yes, because there is a diagonal. C, here's the base, so I need a diagonal that touches that base, and this diagonal right here does not touch the base, so this would be a no. No diagonal support at the base. And now it's time for your homework. You have worksheet 4.1.